Good morning, everyone. I'm Melanie, aerospace engineer and co-founder of FormAlloy. I'm going to talk to you a little bit today about FormAlloy and what we're doing to accelerate the material development in the additive manufacturing space to transition us from ancient times to AM times. At FormAlloy, we design and manufacture metal deposition systems and solutions. And what we've brought to the table today will truly change how metal additive manufacturing proceeds in the future. I want to first start with a brief history of how humans have been using metals over time. So there's historical evidence that humans have been using metals to create rudimentary tools and to improve their lives since 2500 BC and even before that in the late Neolithic ages. They became more advanced, they were using more metals, they were using iron. They started to form their own alloys, such as bronze, and then they started doing the first initial density measurements with metals and being able to measure the metallic properties. Then we became more advanced, and we started developing new alloys that were specific to traditional manufacturing processes, and even developed some super alloys that can be used today. But what we're really lacking in the AM space is a new set of alloys that are optimized for additive manufacturing or optimized for specific applications. And the reason is that alloy development is very expensive and time-consuming. You have to create an alloy in bulk, you have to cast it, and then do all the testing of it. And that's all changing today with the release of the Rapid Alloy Development Feeder. With this feeder, we are able to rapidly deposit various alloy compositions quickly and characterize those compositions to accelerate when we can bring new alloys to the market. This truly does provide unprecedented capability in the material research and development realm, and our feeder is currently in use at the University of California, San Diego and their Department of Nanoengineering for new alloy development. Now a little bit more about how this works. You can see on the left, that is the alloy development feeder, and it's 16 miniature hoppers, which hold about 20 milliliters of powder, which are indexed and rotated to the desired hopper, and then lowered for deposition. On the right-hand side, you see the metal deposition process, where a melt pool is created and the powder is blown into that melt pool. So very quickly, you can synthesize these various alloy combinations without the need to create a bulk of the alloy and then cast it. The system is very powder efficient, up to 95% powder efficiency, and there's virtually unlimited alloy variations that can be created from this system. You can use this not only for rapid alloy development, but also for precise gradient deposition, where you can develop a very specific strategy from transitioning from one material to another and ensure that your layer compositions are as you prescribe them for that specific strategy. So what does this look like? On the left-hand side, you can see a small disc just over the size of a quarter, which has 16 different alloy variations laid on it. Now that can be deposited in a matter of minutes and then fully characterized so that way the next batch can be created until you receive your desired properties. Now this shortens the cycle time of new alloy development from what's measured currently in months and years to what can be measured in days and weeks. On the right-hand side is a gradient material example where multiple materials can be added to a single part for enhanced properties or to combine multiple materials into a single part build. Now we can use a very wide range of materials, everything from nickel and cobalt and iron-based alloys to titanium and copper alloys, pure silicon, and a very wide range of alloys that can be used. So with the virtually unlimited material compositions that can be created and the very quick deposition of materials, we are truly transforming the metal AM space to enable companies to develop these alloys very rapidly so that way we can use them for deposition, for enhanced properties, and improved material properties with the various AM processes. And with that, we are transitioning the industry from ancient to AM. Thank you very much.